Good afternoon. This video will talk about the ice giants. Now, what is an ice giant? An ice giant is basically a giant planet made mostly of heavier elements than hydrogen and helium. For example, Jupiter and Saturn, which are the biggest gas giants in the solar system, are made primarily of hydrogen and a little bit of helium and a little bit of other elements. While Neptune and Uranus are made mostly from about 30% hydrogen and helium. The rest is heavier elements like water, ammonia, methane, a bunch of other heavier gases than those that we know like hydrogen and helium. Now, an ice giant is not a giant ball of ice. Like we just established, it's just made of heavier gases. Like really heavier gases. However, that's not necessarily true to the end, because technically inside of Neptune and Uranus there could be a very thick layer of actual ionized water under high pressure that are liquid and can transfer electricity through the process that creates basically magnetic fields. Now, magnetic field is made by basically a dynamo effect. Now, if we take a rocky planet like the Earth, there is the inner core, outer core, and the outer core is surrounded by the mantle, which is basically molten rock, magma. Now, that magma is going around the outer core and creates a dynamo effect, which basically produces the magnetic field that we have around our planet. Now, the same process basically happens in Neptune and Uranus, but by a different method in a way. Unlike hot rock mantle, there is basically just very high pressured water that goes around the rocky core of Uranus and Neptune. At least this is what we established through some measurements here and there. And so what we think is basically happening is that those water can move the electrons from the core into the outer space to create the magnetic field. But unlike the Earth's magnetic field, which is basically stable in the same angle as the planet is in terms of the axis, in Uranus and Neptune this is a different thing. In their case, the magnetic field can move from 0 degrees to 60 degrees, and it's always flexing, it's always moving. It's not exactly permanent state. It's not always like this. It can move around. Now, Uranus is on its side. Now, why it's on its side? Because in the past it was hit by a number of Earth-sized protoplanets that in a way hit him in a glancing blow, which means they hit him on the top or from the bottom, but not straight up. Now, why we think it was a glancing blow and more than one? Because its ring system, the ring system of Uranus, survived around the equator in orbit around it, which means that whatever hit him didn't hit him so hard that it destroyed the ring system and the moons, but they just transferred them along the ride. The more the planet tilted, the more the ring system and the moons have tilted as well. So they stayed around the planet, but they haven't been destroyed. Now, that's not necessarily true in general, because those moons are always sort of refreshed. Now, we'll talk about it later, but now let's just keep explaining a little bit about the gas giants in general. Now, they are basically the furthest planets from our sun in a way. Now, of course, they are still technically gas giants, but unlike regular gas giants, they are just made of heavier gases like we established. However, in the past, when Jupiter and Saturn were in a orbital resonance, which means resonance, that they made sure that for every orbit of Saturn, Jupiter did twice. 2 orbits, which means the resonance of 1 to 2. Now, when those planets became sync, Jupiter and Saturn, they were able to influence the entire solar system. Now, how they did it? They basically moved Uranus past the orbit of Neptune and made sure that, they moved Neptune past the orbit of Uranus, because in the past it was Jupiter, Saturn, Neptune, and then Uranus. What they did, basically the gravitational influence have been supersized, because influence because of the resonance they had, basically the orbital resonance. They basically able to push Neptune beyond Uranus orbit, which means that Uranus became first in order than Neptune. So Neptune was the last planet from the Sun in terms of the 8 major planets after that time, because it just switched places. Because it first was Neptune-Uranus, now it's Uranus-Neptune. Now, again, ice giants have also a bunch of moons. Uranus have 27, Neptune has about 17 or 18. Now, Uranus is the only gas giant that basically recycles its moons. Now, why it happens? Because we can see that through the years, through the time that it had, the moons have been not that stable. Now, some moons are very close together, and in a couple thousands of years they will collide and you will get a debris field. This debris field will go around into the rings, basically around the planet, and eventually the debris inside of it will just coalesce into new moons. So Uranus is basically recycling the materials to create always new moons. Now, we know about 27 of them, and you know the two that are in collision, going to collide in a couple thousands of years. The point is, Uranus is recycling its moons. However, Neptune has a moon that is actually a very interesting one. But first we're going to talk in this video about Uranus first, since he's the first ice giant as you go away from the Sun. Now Uranus is tilted on its side by about 84 degrees or so, or 89 degrees. So it's basically very tilted. Now, it means that for the 84 years of its orbit around the Sun, each side of it sort of gets towards the Sun, and you get about 20 years or so of really intense summer and winter between autumn and spring. Now, as soon as the sun rays hits the atmosphere of Uranus, you get seasonal storms. Now, unlike Neptune, which we'll talk about a bit later, Uranus have constant seasonal storms, which means when summer arrives, it has very powerful storms. When autumn arrives, it has autumn storms, which are also very powerful, and etc., etc., etc. It just goes on. And about each season goes about 20 years, sort of. It's mixed bag exactly how much it goes, but the point is, Uranus has seasonal storms, not constant ones. So its atmosphere could be very quiet in some seasons and very active in others. Now, other than that, we know it, the same as Neptune, it has an electric field that is also powerful and also tilted between 0 to 60 degrees. The tilt is going one way or another. And overall, it doesn't really have a lot of features besides the seasonal storms. It's mostly a really pale ball that we can see in some times, and sometimes it's a very active pale ball that we can see in other times. Now, Neptune, of course, has been only basically pictured and having some was able to be studied by the Voyager spacecraft, which was able to fly by him in the end of the 70s, starting 80s, and so on, between those years. Now, beyond that, we didn't send any probes to investigate, but we do know that some of its moons are very interesting. Some of its features of those moons, and just features of the planet itself, could be very interesting. But overall, it's a very calm planet most of the time. But sometimes it gets really powerful storms and really strong winds that are starting to blow around it. Now, if we're gonna check just a little bit of it, this picture, just for the emphasis, is basically what Voyager 2, the Voyager 2 probe was able to picture at that time. Now, as you see, it's very pale and it doesn't really have a lot of activity in it. However, if we go just to Uranus to explain, of course, by the way, if you wanted to know, I don't know if you know that or not, but basically, its mass, in a way, it's about 14 times that of Earth's, and his main density is showing 1.27 grams per cubic centimeter, if you really want to know. Point is, we have a couple of examples, like here, you can see the rings of Uranus, and the planet itself is very tilted in that way. Now, this is simulated view made even up to 2030, but the point is, this is how it's basically in some way tilted, just for the knowledge. Now it's a size comparison, of course. As you can see, Uranus and Earth, Uranus is about 14 times more massive and definitely a couple of times bigger than our planet, but it's, you can see it's a gas giant, but made of heavier gases and so on. Now this shows the layer of basically of Uranus, if you see. Now it has most likely rocky core, water, ammonia, sea, which creates magnetic field we see, and you have also like the couple of rings here and there. It's a very interesting system. It also has some of the moons here that you can see. Overall, this is it's interesting planet when it's quiet, but it also has, like I said, seasonal storms. So in some times of its year around the sun, well, it basically takes 84 years to go around the sun. Some of the time is not that active, some of the time it's actually very active. Now this was cut by the Hubble Space Telescope, and you can see some storm, which means it's got into a seasonal time in its orbit that can create those kind of storms, like this spot here, and you can see it's grainy, but the point is it was very active at that time. Here you can even see the north pole of it. When it goes towards the sun, it gets really hot and it creates a change in pressure and all that, and can create a really hot spot that basically drives a bunch of winds on it. And those winds can be very powerful and go around the planet. Here you can see some of the time lapse of this dynamic atmosphere when the time is right in its orbit, for example. And here you can even see a really big storm that basically goes for about 8,000 kilometers wide. It's very big. It's more than half the size of the Earth. Here you can even see, just for an example, it's in 2005. You can see the rings, you can see some storms, again by the Hubble Space Telescope in this case. Here's the magnetic field. As you can see, it's very unstable, doesn't stay tilted the same way always, and it's always moving, because we'll explain this a little bit. Because it's a gas giant planet in a way. It's made of solid surface. So the magnetic field is always moving and always tangled. The same with Jupiter, Saturn, and Neptune, of course. So this is just an example, a little bit of it, and so on. This is basically north-south pole. As you can see, it's twisted because its north pole is actually more in this area than this area and all that stuff. Here is some of its pictures that were made by Hubble. As you can see, the storms, here they are, the rings. Here are some of its moons in order, as you can see. From left to right, Miranda, Ariel, Umbrella, Titania, and Oberon. Some kind of, it's a bit hard to say those names, but the point is, those are 5 of his 27 moons we know of. Those are the moons, as you can see, and this is the ring and all that stuff. So it's a very interesting thing. And here you can see some of the rings in much better color by the James Webb Space Telescope near infrared camera, which can see heat signatures, which is very cool. Here you can see Uranus. From the Cassini spacecraft at Saturn, you can see the little dot is Uranus. That tiny little dot, right about here. So on, this is not... The point is, this is Uranus. Now, we're going to talk now about another planet. Now we're going to talk about Neptune. I'm going to keep it pretty simple, but follow me up. Neptune is the last planet from the Sun. It's over 3 billion miles away from the Sun. But unlike Uranus, this planet, Neptune, has constant storms. Not seasonal ones, constant ones. Now that means that throughout its 165-year orbit around the Sun, it always have storms and always have winds, and of course it always have activity in its atmosphere. Now, why is that? Neptune has the fastest winds in the solar system. From any planet or any object that we know in the solar system, it has the fastest wind speeds. It's over 1,500 kilometers per hour. Just for reference, Jupiter's highest wind speed in the atmosphere in general, not in the storms themselves, I'm talking in the general atmosphere, is almost 500 kilometers per hour, about 480 kilometers. Saturn has about the same speed, so to speak. Uranus have higher speeds, but only seasonal ones. Neptune has a constant over 1500 kilometers per hour wind. Now, it's basically, now you ask yourself, how the hell it has this kind of wind? Well, technically, it's so far away from the sun. Now, every planet that is created through a process of accretion, and that accretion generates heat. So when the planet is being born, it has basically heat. That heat goes from the core to space over billions of years. So Neptune basically is just releasing heat from the time it was created, from the time it was born. Now, Neptune has about 17 or 18 moons, if I'm not mistaken, but it has basically, has a bunch of storms like we talked about, and overall it has a lot of interesting stuff. Now I will start with the storms. Now the biggest storm we saw was the Great Dark Spot, which basically was about the size of the Earth. It was pictured by Voyager 1 when it crossed it, and Voyager 2 as well, and you saw that spot. But now we saw that those spots are changing their spots, if you will. They move from being where we saw them before to different areas through the atmosphere. Now, some of the atmosphere you can see in some areas, you would see white stuff like the white clouds or whatever. Now, this is basically just because Neptune is made, like I said at the start, from heavier gases: ammonia, methane, water, a bunch of other stuff. Now, we're gonna a little bit talk about them, but just for an example and just for reference, I will also show that too. Neptune has 16 known satellites, like I said. Basically I said 17, but it's 16, and it takes almost 165 years. But what is most interesting is basically his mass. Now, his mass is about over 17 times the mass of the Earth, while its radius is actually almost 4 times. It's a very big planet, but again, it's not the biggest we have, but it's very cool indeed. Now, as we can see in this picture, for example, you can see the size difference between those two. Now, Earth is a rocky planet. This is an ice giant planet. It's a gas giant made of heavier gases, or ices, if you will. And this just shows a little bit of its inner structure. As we already established, it has magnetic field, of course, rotating pole. It has some rings as well. It has also some moons like Triton and all that stuff. And other moons as well. All that stuff, it's very interesting. This is a picture of a near-infrared image by the Hubble Space Telescope. Shows bands of methane in its atmosphere. The white stuff, or this, you can see the red stuff in this case, are methane clouds in its atmosphere. And it has 4 moons here, but it has, like I said, 16. And this is an interesting topic. Now, as you can see, it shows a bunch of years, through the years, the changes in the Neptune's atmosphere. Like in 1994 it was like this, 1998 it was like this, and as you can see in some areas the spot has been moving, and there was other spots being created in the atmosphere, other storms. Interesting thing, like this is show the changes the planet has been going through from 1994 up to 2020 in this case. Here you can see some of the Voyager 2 images of the methane clouds. Right about here, those white streaks are the methane clouds in its atmosphere, upper atmosphere. Now, this is another image, shows his color, which, by the way, it's not that blue, but it was basically made here with combination of a couple of colors just to exaggerate them in this case. But you still can see white, you can see the Great Dark Spot, which has moved, and you can see even another spot right here. So it's a bit paler than here, but they just made an emphasis to exaggerate. This is his actual color, which is recalibrated to show much more authentic color, which is more paler, not as blue as you saw before, but still but you can see still the storms. It's just made again. This is another recalibration from 2023. It also shows much paler, like Uranus, but still with the storms and the white clouds. And here you can see with the gray dark spot even better here, closer, with another storm right down here. For example, this is even a closer image of the gray dark spot. Now, overall, you can see here other storms have been created. And as you can see, it really shows from November 2018 the difference between the other pictures, but it's still grainy because it's very further out, but you can see some storms and some clouds and literally a different version. Here you can see another gray dark spot, but basically a smaller one than before and in a different area than in the equator like last time. And here you can see the difference between 2015 to 2017 as the storm changes places and eventually just changes colors or disappearing altogether. This is another picture that shows him with the different sides, different storms, but still, this is Neptune. It has a constant wind, not just a seasonal one, so it has constant storms. Basically, it's its orbit around the sun. This just shows other stuff. Now, this shows Triton, his biggest moon, and other moons around his ring systems. In this case, it was pictured by James Webb Space Telescope. This is a closer one with the James Webb Space Telescope of its rings and some moons, and Neptune, of course, itself. This is movement of Neptune in front of stars in Aquarius, in the constellation Aquarius, as it moved past that. Now, this just shows the Voyager 1, Voyager 2, and this is we go back. Now, of course, Triton, in this case, I will talk a little bit about Triton, and this will be kind of the end of this video for now. Now, talk about Triton is the only big moon in the solar system, the round big moon. This goes in a retrograde orbit, which means it will orbit Neptune in the opposite direction of the planet's spin, which means the planet spins like this, then Triton moves in the opposite direction. Now, this creates a constant battle between Triton and Neptune. And we think that Triton wasn't formed near Neptune, but it was captured by it a long time ago when it came with his original partner from the Kuiper belt. And then Neptune captured it, and now this explains his retrograde orbit. And we will talk about Neptune in a different video, about Triton in a different video. So I hope you enjoyed this video about the ice giants in our solar system. Hope I explained it pretty good, and I will see you again in the next video. Goodbye.